Welcome back. As promised earlier in the introduction, we are going to give examples on problems involving arithmetic sequence and geometric sequence. So let's start by examples. So we have check whether the sequence 3, 8, 13, 18 is an arithmetic sequence. And if so, find its 10th and 15th term. So we have to check whether the given sequence is arithmetic, and if so, to find the 10th and 15th term. Now, to test that a sequence is arithmetic, we simply have to show that the difference between all the consecutive terms is a constant, D. So solution. So the first term is 3, second term is 8, third term is 13, fourth term is 18. So let's check T2 minus T1, which will be 8 minus 3, we get 5. Then T3 minus T2 will be 13 minus 8, which is also 5. T4 minus T3 is 18 minus 13. This is also 5. So since there's a constant difference, between consecutive terms, then the given series, the given sequence is arithmetic. And then since now we have arithmetic, sequence, we know that Tn is A plus n minus 1 times D. So in our case, A is given by 3, and D from our calculation is 5. So this means the 10th term will be 3 plus 10 minus 1 times 5, which will be 3 plus 9 times 5, which will be 3 plus 45, which gives you 48. And then the 15th term will be given by 3 plus 15 minus 1 multiplied by 5, which is 3 plus 14 times 5, which is the same as 3 plus 70, which is 73. Next question. Question 2, show that the sequence 3, 6, 12, 24, etc. is a geometric sequence. And then B, of the question, part B of the question, is to determine the common ratio, determine the common ratio and hence find the sixth term. So what we have to show is that the ratio of consecutive terms is uniform. So solution in A, T1 is 3, T2 is 6, T3 12, T4 24. So T2 over T1 is 6 over 3, which is 2. And then T3 over T2 is 12 over 6, which is 2. And T4 over T3 is 24 over 12, which is 2. So since this is a common ratio, for consecutive terms, then 3, 6, 12, 24 is a geometric sequence. And then part B, so therefore from part A, R is 2, and we know that A is the same as T1, which is 3. Nth term of an AP, or nth term of a geometric sequence is given by A times R raised power n minus 1. So when we have to get sixth term, n is 6, so we'll have 3 times 2 power 6 minus 1, 3 times 2 power 5, so which is 3 times 32, which is 96. Then next question, 3. Find the 9th term, the 16th term, of the series of the sequence 2, 7, 12, 17, etc. Now let's see. Clearly, this cannot be a geometric sequence because if we see the 7 over 2 is different from 12 over 7. So possibly let's test whether it's an arithmetic sequence. So 7 minus 2 is 5. 12 minus 7 is 5. And 17 minus 12 is 5. So this implies D equals to 5. So we have an arithmetic sequence. And A is 2. We know that nth term is A plus n minus 1 times D. So when you want to get ninth term, n will be 9. So T9 will be 2 plus 9 minus 1 times 5. 2 times 2 plus 8 times 5, which will be 42. And then 16th term means n is 16, so we have 2 plus 16 minus 1 times 5. 2 plus 15 times 5, so 2 plus 75, which is 77. And then next question. The sixth term an AP is 17, and the 13th term is at 8. Find the 19th term. So find the 19th term of this given sequence. So for AP solution, nth term of AP is Tn equals to A plus n minus 1 D. So this implies sixth term, n is 6, so we'll have A plus 6 minus 1 times D should give us 17. So which means A plus 5D equals to 17. So we call this one equation 1. Then 13th term, n is 13, which will be A plus 13 minus 1 times D. They claim that the answer should be 38. So this will have A plus 12D equals to 38. Call this one equation 2. Then you solve 1 and 2 simultaneously. So solving 1 and 2. So if I say equation 1 plus equation 2 minus equation 2, I'll have A minus A is 0, 5 minus 12 is minus 7D, 17 minus 38, we get minus 21. So which means D will be minus 21 over minus 7, which is 3. And then, so from the first one, A will be 17 minus 5 times D, which is 3. So 17 minus 15, which is 2. So the first term is 2, common difference 3. So now to get the 19th term, we'll have T19 will be A plus 19 minus 1 times D, which will be A, which is 2, plus 19 minus 1 times D, which is 3. So 2 plus 18 times 3. 18 by 3 is 54. So this will be 2 plus 54, which gives us 56. Next question. The second term of a geometric sequence is 27, and the fourth term is 3. So find the first term and common ratio. B, hence find the fifth term. So clearly we have been told that the given sequence is geometric. So we know that for a geometric sequence, nth term is given by a r n minus 1. So when we are told that the second term is 27, so T2 equals to a r2 minus 1 should be 27. This implies AR is 27. And fourth term is 3. Fourth term, T4 is A4 minus 1. So the answer should be 3. So which means AR power 3 is 3. So let's call this one equation 1. Let's call this one equation 2. Now, if I say equation 2 divided by equation 1, I'll have AR cubed over AR equals to 3 over 27. And clearly, this will give us A and A cancels us, so we'll have R squared equals to 1 over 9, which means R will be square root of 1 over 9. So R is plus or minus a third. So this means from equation 1, A times plus or minus a third, which is the value of R, should be 27. So which means A is the same as plus or minus 27 times 3. So A is plus or minus 81. Hence, the first term is plus or minus 81, and common ratio is plus or minus 1 over 3. Part B, fifth term will be AR5 minus 1. So it will be plus or minus 81 times plus or minus 1 over 3 raised to power 4, which is the same as plus or minus 81 times 1 over 81, and this will give us plus or minus 1. So this is the fifth term. So which means that for A as minus 81, T5 equals to minus 1, and for A positive 81, T5 is positive 1. Ensure that you take care of all the negatives from the point you are defining the square root. Then the last question. Find the ninth term of the sequence 92, 89, 86, 83. So quick solution, we have A is 92, Now, 89 minus 92 gives us minus 3. 86 minus 89 gives us minus 3. Similarly, 83 minus 86 gives us minus 3. So which means our D is minus 3. So this is an arithmetic sequence. So whose nth term is given by A plus n minus 1 times D. So our interest is to get the 9th term. So n is 9, will be A, which is 92, plus 9 minus 1 times D, which is minus 3. So this will be 92 plus 8 times minus 3. So 92 minus 24. And 92, when you subtract 24, you get 68. So this will give you 68. So that is how we solve that given problem. Maybe this one, the 5th term of an arithmetic sequence is 30, and its 7th term is 44. Find the first term and the common ratio, common difference, not common ratio, common difference, and hence find the 11th term. So this question is testing about arithmetic sequence, and we know that nth term for arithmetic sequence is A plus n minus 1 times D. So when you say 5th term, we mean n is 5. So T5 will be A plus 5 minus 1 times D, and we should get 30. And 7th term means n is 7, so it will be A plus 7 minus 1 times D, get 44. So from T5, we have A plus 4D equals to 30. I call it equation 1. From T7, we have A plus 6D equals to 44. Call it equation 2. So solving 1 and 2, if I subtract them, 6D minus 4D is 2D. 44 minus 30 is 14. So this means D equals to 7. Now, from the first equation, A is the same as 30 minus 4D, which will be 30 minus 4 times 7. So 30 minus 28, which is 2. So therefore, D equals to 7 and A equals to 2. And the first term is 2, and common difference is 7. Then we had to find those two values and find the 11th term. So 11th term, T11, will be A plus 11 minus 1D. So which will be A, which is 2, into 11 minus 1 times D, which is 7. So 2 plus 10 times 7. So 2 plus 70. which is 72. So this is the answer to that question. Next session, we will do problems involving summation of terms in arithmetic sequence and geometric sequence. Thank you.